Hello, it's me again. I'm just you can see exactly the same around me. It just I just record the second video straight after the one that you watched before. So I'm trying to continue what we learning. The one that I discussed before would be all about thermodynamic chemical reactions, and those thermodynamic chemical reactions, you can use it to do the calculations. And those calculations say, I give you 10 grams of hydrogens, and then what would be the delta H? So and then you would try to play around with flipping the reactions and try to double or triple those reactions. So that's hopefully you understand what's going on, and also related to the energy profile. You need to know when you look at the energy profile straight away, tell me what is exothermic, what is endothermic reactions. So let's say I give you these examples here. So that one start from the top, get down to below, and then the other one I give you the ideas, start from low and then up to above. So that one in the beginning, go down at the end. The other one from the low move all the way to the top. So both of them, which one is exothermic, which one is endothermic? So I write down exothermics here and endothermic right in the middle. And the side, this is the left hand side. The left hand side is from the top to the bottoms. As we know that the delta H can be calculated by the product, take away the reactants. So if you do product, take away the reactants, that one would be a negative values for the first one on the left hand side. And the delta H for the right hand side, which is if you do the product, take away the reactants, which give you a positive values. So it's easy to start. So let's say this is 10, you end up with 60. This is 60, end up with 10. Then that one would be 10 minus 60, give you negative 50 kJ. I have been saying G last time or the last video, so that's a bit weird for me when I to watch it back. I'll make sure myself we say kJ again. So P, this product that is 60, then take away the 10, we have 50 kJ, right? But that one is a positive values, and the other one is a negative values. So which one is exothermic or endothermic? Please, one more time, when you say negative, it means release. And when you say positive, it doesn't mean positive, it only means absorbed. So when energy being absorbed, definitely moving all the way to the up. So endothermic is heat absorbed reactions. And exothermic is the other way around, is a heat released reactions. Okay, so hopefully that will give you some ideas what's going on from last class. Then let's move on to a very later topics. I like to discuss water today, or for this particular clip. It's about heat capacity. If you do physics, so this is also a topic that you need to do in your physics course. Heat capacity of water. So what does that mean? It means that water, you need to put heat into it in order to change its temperature. It holding some of the energies and turn its temperature. And the temperature in the heat capacity of water, we call is very, very high. And if you look at heat capacity of water, it's actually a particular chemical phenomenon or observation that we've done so far to control our weather. When the weather is very wild, it means that there's lots of rains around us. When the coal turn into the heat and the energy release, because most of the time water trap a lot of energies. When you release, then things change. I'm not going into details for those reactions, but heat capacity is very important for weather, for our life, even you, when I'm speaking, the heat capacity of water still control my body temperature as a very steady way. So heat capacity of water, what does that mean? It means how much energies we used J, Joule, is needs to increase 1 degree Celsius of water. So say it one more time. It has two sides. One side is how much energies. The second side is increase 1 degree of Celsius of water. So what is the values? And the values basically called 1 calorie. 1 calories, 1 C. So when you say, how much calorie have you burned? We use this simple concept to measure them. So let's say 1,000 calories been burned. It just means that you can increase those temperature by 1 degrees. Then you say that, that doesn't make sense because just 1 degrees of how much does it need? So let's say if I change my body temperature by 1 degrees for a kid with only 20K compared with me with 60K, definitely would have different energies would be needed. My one would be needed more and the little one would be needed less. So what do we do? One more concept that we need is we need to know that how much 1 mole. So heat capacity of water, we'll be talking about 1 calories is equals to increase 1 mole of water. So let's say if you have a cube, that is 1 mole of water fully filled. You increase that one by 1 degrees. That is what we call 1 calories. Then what happens if you have to change calories into J? And there's a very simple conversion. All you need to do is times it by 4.2. There's supposed to be 4.2 something. I'll give you exact values. Try to use this one at this moment, because everything's in the data booklet. You can always check that later on. So assume this is 4.2, suppose 4.18, but 4.2, just make it easier for calculations today. That means for all water, its heat capacity will be 4.2 Joule per mole per degree Celsius. So it has a very, very long unit. It's a Joule per mole per degree Celsius. Some other people also write down J, ml minus 1, and degrees minus 1. Okay, so if you times the whole thing by 1,000 times, so 4.2 J times it by 1,000, it makes 4.2 kJ. Does it make sense? A 4.2 kJ can be written by this. Can be written by, it would be 4.2 kJ is needed to release 1 liters of water by 1 degrees. Right? From 1 mil into 1,000, you need 1,000 times more energies to increase. So 4.2 depends on if you're just looking at in mil. So you use 4.2 J. If you're looking at liters, much bigger values, we use kilojoules. Right? So hope you understand the unit a little bit. Then what happened? Just give a very simple calculation. It's all about calculation today. If I've got the initial temperature, temperature 1, initial temperature is equals to 21 degrees. So let's say I will put a glass of water, right? and this glass of water is about 200 ml, right? Let's try to draw a microwave. So this is my perfect microwave, and we've got the dot there and blah blah, and then we just put a start there. And the brain would be Joey brain. Now that's a microwave. I put that into the microwave and I started it, and let's say I take 1 minute. So just you can try at home, just a glass, or don't use metal glass, just normal glass of water. Put it in 200 ml. It's about 21 degrees initially. Then you heat it up. Once you heat it up, it ends up with T2, which is, let's say, 89 degrees. So very ugly numbers, and I hate doing all the calculation. It's not that hard. And the next question I would ask you would be, how much energies have you put into the water by the microwave? So if you look at that, very simple calculations. Energy is equals to mc delta T. What mc delta T means is this is the energy input. How much energy input is in there with this water, the mass. M stands for the mass of water, and C just basically stands for 4.2 joule. It means what? Heat capacity of water, that value. mc delta T. Delta means change, T means temperature, so which is the change of temperature. How much value? The things that I want is the energies, and I have what do we have? We have the delta T, which is we have the C, which is 4.2. We have the delta T, easy, 89 take away 21. Then where can we find the mass of water? The mass of water can be found by the volume. 200 ml of water we basically assume equals to 200 grams in chemistry. Very, very straightforward. If you find that like the 200.00015 something, that's ridiculous. And the exam paper would be checked by lots of others, would be eliminated. Those questions would not happen, would not appear at all. So energies is equals to, the mass is 200 grams times it by 4.2, and then we times it by delta T, which is 89 take away 21. Then 200 times it by 4.2 times it by 68. Then let's try to do my calculator again. So let's say 200, let's cancel it, 200 times it by 4.2, then times it by 68 degrees is 57,120. So that one is 57,120 joule is needed. Because the number seems too big, we change that into kilojoules. Is 57.12 kJ. Right? Make sense? So this is basically how do we use water or heat capacity to find out the energies that we put into it. Then another question that you may find, this is my cheat sheet, I need to look at it and keep doing it. Another thing that you may see is when you go to check your microwave on the side, they always give you a value, say how much watt does it produce, and what is the watt? So hopefully a physics students are relying on you. You should be able to tell me what is the watt. If you ask me that, I'm not physics expert, but watt is equals to how much energy is given per second. So is a unit to measure the rate of energies given to you. So if I'm using, saying, a 60 volt light globes, that means that 60 globes, that one use 60 joule per second. Right, so if I'm going to give you electricity, then I can use volt. I can use how much volt that's been given to you times it by the time. Then I can charge you with the energy that you use. So volt is joule energy per second. Then you always find that, like, if you go and check next to the microwave, they always say there's like 1000 volt and 800 volt or 1200 volt or 1600 volt. Make it easy. Let's say if I say I want to find out the volt, how much energy, what is the volt that's given by my super microwave. So I've done 1 minute, and they changed that into 21 degrees to 89 degrees Celsius. And I know that I've been producing 57,120 joules in 60 seconds. So what we do, what for my microwave would be easy to calculate. The microwave give out 57,120 joules in 60 seconds. In 60 seconds, the answer would be 952. The microwave is close to 1000, right? Pretty close. So try to put 200 ml of water in the microwave, change the temperature, and you may be able to claim, okay, going back to check your microwave whether it's still in good condition. Because if it's like saying that it's 1800 volt, it only gives you like 1000 volt. Then you know that it's going downhill. The energy input and some things may not be what it claims, right? So I hope it makes sense to you so far with the heat capacity of water. And it's a simple calculation, or simple. You can do this estimation, or you can try it at home and see to do the calculation for your microwave. Then, as I say, there will be lots of calculation today. So the next calculation that you do, I basically call them estimation method. Estimation method for finding delta H. This is not accurate at all because there's a lot of heat lost in between the process. But this is one, if you don't have a good measurement or good device, it's a good estimation method. Estimation that's what we do, and it's something that you need to know and something that you need to kind of understand in a year 12 course. So what do? We use the heat capacity of water to find out the delta H of a chemical reactions. The chemical reaction I use today would be acid and base. Acid react with base. What do we call them? Hopefully come up into your mind. Something start with N. It's called neutralization. Yep. Neutralization, something neutral with one another. Acid will neutralize base, base neutralize acid. Then, if I have a very simple reaction, which is hydrochloric acid react with sodium hydroxide, I need you to tell me about the product. So what would be the product? The product would be salt, sodium chloride, and water, H2O. So HCl is in aqueous form. That in aqueous form, salt is able to dissolve, and water by itself not breaking is liquid. So this is a simple neutralization reaction. Hydrochloric acid react with sodium hydroxide, forming salt and water. So they're 1-to-1 ratio. So nothing very special, nothing fancy. But how can I use the estimation method based on energy equals to mc delta T as the estimate measure, to estimate what would be the delta H for these reactions. Right? One condition that we need to assume is we need to assume most of the chemical dissolve in water. Okay, they are in aqueous, and this aqueous is not that concentrated. It's not so concentrated. Doesn't really change. So the salt or the things that dissolve in it, the chemical dissolve in it, the ion dissolve in it, doesn't really change much density of the water. So the salt dissolve in it, not changing too much density of the solution. So it's like 1 spoon of salt into 2 spoons of salt into it, still manageable. We are kind of like, okay, assume that those in salt in the solution doesn't change the overall mass too much. So we're still happy with just taking the mass of water, right? mcΔt for estimation, the mass here, not the mass of your chemical, is the mass of the water only. Most of the students make this one so confused, saying that good question, give me 5 grams of sodium hydroxide and I have to use 5 grams. Then you're wrong. I'm sure you're 100% wrong, because the delta T there, the delta T you're measuring is in the water, and most of the substance that you're going to measure in those estimation methods is in water. And you would be 100% wrong if you only take the chemical, the mass of the chemical. But you are 99% correct if you're taking the mass of water, right? So we have to make sure that the assumptions are right. The salt that you have in there doesn't change much. Okay, the chemical, let's say the hydrochloric acid in the when they dissolve, the mass of hydrochloric acid doesn't really change the mass of water too much, right? If you use the mass of a chemical, then you're only 99% wrong, but you are using the mass of water, because the mass from the reaction from the one that you're looking at, 99% of the mass coming from water, then you're 99% correct. So whether you can choose 99% correct or 99% incorrect. So make sure, one more time, never use just the mass of the chemicals. Right? So let's try to do some revisions. What is acid and base reactions? Acid and base reactions, we call them neutralization, and neutralization has another term. It's called hydrogen ion proton transfer reactions. This is one of the definitions. Not all of the textbooks agree with that, but in year 12 it's more than enough. Okay, so you're more than enough to say neutralization is hydrogen ion or proton transfer reactions. That's full stop. And when acid is the one that giving out the protons to the base, so acid equals to proton donor, and base is equals to proton receiver. Terrible writing, but you understand. Then, so let's go back to the rule. Let's go back to what do we do? How do we do the estimations? Then I give you a bit more values. You'll understand what's going on. So let's say I've got 50 ml of acid. Going to react with 50 ml of sodium hydroxide and mix them together in a bigger flask. And this finished, we've got the product. And inside the product, we know that is the exothermic reactions. This is the exothermic reactions. When it's exothermic reaction, those things react, and you'll find that the temperature. So that's the interesting things to look at. The systems in here, because it's the product, it's the hydrochloric acid and sodium hydroxide, and we have kind of what we call the surrounding, right? In generally, we should check the temperature of the surrounding. And wait for the heat leaving from the system into the surrounding. Then we are able to measure the exothermic reactions, right? But because there's lots of heat loss, if you just wait until to get the system into the surrounding, that's not very accurate. The more accurate way is to measure directly your system first. So if your system change, and then the heat energy will eventually leaving your system into the surrounding. So the temperature change of your system would tell a lot into you. It makes sense. Hopefully it makes sense to you. So then we need to do is to mix those hydrochloric acid with the sodium hydroxide. Then we put a thermometer into the flask and look at the temperature change. Right? Easy. A mixed with B, a thermometers into it, look at the thermometer and temperature change, full stop. Then all the information you need would be here. You need the initial temperature, T1. Let's say initial temperature is 20 degrees for both of the hydrochloric acid and sodium hydroxide. Then when you mix it with it, which is at the end of the reaction, when after they mix, is equals to 28 degrees. The delta T equals to 8, right? Then the other thing that you need to know is what would be your mass of your sodium hydroxide and the hydrochloric acid, and the mass of the sodium hydroxide, which is given by the volume. So let's say I've got 50 mils in there, 50 mils, and 50 mils, I told you before, we assume that is equals to 50 grams. 50 grams. I make it extremely easy. I give you the best value. 50 plus 50 equals to 100, and 100 is easy to calculate, right? 50 plus 50 equals to 100 mil. So we have 100 mil at the end of the reactions. Then the other thing that you need to do is you need to find out the concentrations, because as I say, you're dissolving things into your water. So it's an aqueous solution. Or aqueous solution, you have to look for the concentrations. Nothing, you can't escape. Hydrochloric acid is 1.2 m, so as the concentration of the sodium hydroxide is 1.2 m. Now we've got everything. You have every single thing to find out the estimate the delta H of neutralizations. So make sure that you know what is your purpose. Your purpose is to find out the delta H of the neutralization, or the delta H of the proton transfer reaction. Yes? What do? We start from energies equals to step 1, mc delta T. What is the energy input is very important to find out. We can find out energy input by the mass. What do we use? Do we use 1.2? Do we use 1.2? No, you can't. You have to use the mass of water. And this mass of water is at the end of the reaction, which is 100 grams. Times by the delta, the C is always 4.2. 4.2 is like water, heat capacity, and you're looking at water. Delta T is 28 minus 20. Right? Let's have a look. 100 times 4.2 times 8. 100 times 4.2 times by 8, not 4 point, sorry. One more time, 100 times by 4.2 times by 8 equals to 3,360. 3,360 joule is produced. Okay? That's all like, yeah, what's the next step? So I know how much energy is released from mixing two things together. Then what else do? Is we would be able to look at the concentrations first. As the concentration hydrochloric acid react with sodium hydroxide, they are 1-to-1 ratio. And that means the number of mole that you need to neutralize both of them is 1-to-1. So what is the number of mole of sodium hydrogen chloride, hydrochloric acid? N is equals to concentration times volume. What is the concentration we've got here? 1.2 m. M means molarity, 1.2. Then times it by 50 ml. Do you times it by 50 straight away? No, because it has to be in liters. You need to divide it by 1,000. Then you will find that 1.2 times it by 5 equals to 6. Yeah, 6. Then it's 60. Then you have 30. 1, 2, 3. I say that's 0.06 mole in there. Right, let's double check. It's 1.2 times by 50 divided by 1,000. 1.2 times by 50 divided by 1,000. 0.06. 0.06 mole is what you have for sodium for hydrochloric acid. Number of mole of HCl is equals to number of mole of NaOH. So both of them is 0.06 mole. What is delta H? How do we find delta H? Delta H is 1 mole of HCl reacts with 1 mole of NaOH according to the equations. Now, delta H equals to the energies per 1 mole of hydrochloric acid. Right? So delta H divided by 1 is equals to how many moles? 0.06 mole there. 0.06 mole is reacted between 0.06 mole and 0.06 mole sodium hydroxide, and it gives 3,360 joules. It gives 3,360 joules. Then delta H is equals to 3,000 divided by 0.06. 3,360 divided by 0.06 equals to pretty big number, 56,000. 56,000 joules. And one thing this time, because I'm asking you the delta H, and because when I ask you delta H, you have to put a negative there. You don't need to write any sentence at all, because delta H, negative means release. And it's equals to negative 56 kJ as your answer per mole, because delta H need to be mol minus 1. Right? Yep. Another half an hour video, and I give you so what I give you today would be just all the calculation methods. So you will find that the first one, I can give you ideas about how to use mcΔt when you have just a water temperature change. Then I give you the estimation method. The estimation method is something that you will do a prac later on in the term and find out the answer yourself. And is try to do the delta T, the delta H. neutralizations. And the delta H estimation would be 56 kilojoules if all the data's here. So we can do this in class when I come back straight away. Okay, another time. So please start doing your 10 guided questions and spend another 20 minutes on. Okay, and make sure you do your homework too. Thank you so much. See you. Bye.